In this video, we'll be discussing the steel phase diagram. We will be focusing on the different phases that appear in the steel phase diagram and the transformation of the microstructures. So, some definitions. Pure iron is ductile and therefore not very useful for most structural applications. How can we change that? By adding carbon to the iron. And the steel phase diagram explains us what happens as carbon is added to iron. As the concentration of carbon increases, the phases change as well as the crystal structures change. And there are some classification of the material depending on the concentration of carbon. So between 0.0 and 0.008% concentration is commercially pure iron. Between 0.008 and 2.12% carbon, those are called steels. And in between 2.14 and 6.7%, those are called percent carbon. Those are called cast irons. Above 6.7% carbon, that's not very useful for engineers. And just as a side note, as we add carbons to the iron, the material gets stronger and the corrosion resistance is improved. So let's go ahead and let's look at the steel phase diagram. Let's focus really quickly on the different phases. Right here, we start with the liquid phase, just as the binary system. And this line right here, this line is actually called cementite. So as you cross this line, you start getting liquid and cementite. And as you cross this line, you start getting liquid and austenite. This entire area is composed of austenite iron. This, as you cross, as you add more carbon, you start getting austenite and cementite. But as you lower the temperature, you start getting ferrite and cementite. This line right here is ferrite. So as you can see, there is a difference. There is a huge difference between the steel phase diagram and the binary system diagram. We in the video in regards to the binary system diagram, we had mentioned that the eutectic point happens when you go from pure liquid to liquid plus solid, and that is happening right here. So in this case, this is where the eutectic point is, and this line is where the eutectic reaction is happening, right at this temperature right here. But now we have a new point, this point right here, and this point is called the eutectoid. Point, and this is where the reaction is happening right here at this temperature. And the eutectoid happens when we go from austenite to solid with cementite. When we are analyzing steel phase diagrams, we usually focus more on this area right here. And that is where we're going to focus on our discussion of the microstructures. Just as the eutectic, as in this binary system diagram, the eutectic point divided the diagram in two, and in two, it divided it into hypoeutectic and hypereutectic. The eutectoid point also divides the diagram into hypoeutectoid and hypereutectoid. So now that we have all the faces clear, let's go ahead and take a look at the microstructures. So this right here, as I just said, this is the eutectoid point. This area right here is hypoeutectoid, and this area right here is hypereutectoid. In the hypoeutectoid area, it is going from 100%, 100% austenite to alpha plus austenite. And later, alpha, which is also called ferrite, plus cementite. Because we have 100% austenite, we get this microstructure, which is pure solid with the grain boundaries happening. And then as you lower the temperature, this grain, wherever the grain boundary is, it starts to become ferrite. And you still have little concentrations of austenite. The composition, the microstructure at the eutectic point is also called pearlite, which is something very similar to eutectoid. You have the different you have a mixture of cementite and ferrite. And remember, this is also called pearlite. But pearlite is not a phase, it's a microstructure. So the name of the eutectoid phase microstructure is pearlite. And as you lower the temperature, you get this concentrations of pearlite inside of the same alpha phase. It is important to point out that right here, this is 100% pearlite, but right here at this point, it is 100% proeutectoid. This is called proeutectoid. So now that we took a close look at the hypoeutectic area, let's go ahead and focus on the hypereutectic area. So now we also have 100% austenite, the same microstructure as before, but now as you lower the temperature, you start getting the concentrations of austenite inside of cementite in the same place where the grain boundaries were. And as you decrease the temperature even more, you get right here the pearlite microstructure, and then you get the perlite concentrations inside of cementite areas. And that is an overall look at the steel phase diagram evolution of its microstructures and its distinct phases.